The goal of this video is to be able to draw free body diagrams so as to clearly show the forces acting on an object. Consider a mass hanging by a string attached to the ceiling. It should be immediately evident that there are two forces acting on the mass: the force due to gravity pulling it down, and the force from the string holding it up, which we call the tension force. We can show these forces by drawing arrows on the object, and labeling those arrows according to the forces they represent. There is a downward arrow showing the force of gravity, and an upward arrow where the string is showing the force of tension. The size of these arrows correspond to the magnitude of the forces. If we know the mass to be at rest, the arrows should be drawn with the same length. The force of gravity is also known as weight, so we might abbreviate these forces as T for tension and W for weight. To draw a free body diagram of the object, we simply show a small dot representing the mass and draw the forces in as arrows that originate on the dot. This makes it easy to see the forces in relation to each other and allows for a quick and easy sketch of the situation. If somebody comes along to pull on the object with another string, we simply add that arrow into our free body diagram. Since the force is acting through a string, we would be just as correct to label it as another tension, in which case we need to differentiate it from the other tension force by using subscripts. If the strings are at different angles to a chosen axis, then we draw the forces on the free body diagram accordingly. Again, the size of the arrow corresponds to the magnitude of the forces. The vectors shown can be broken into x and y components, and if the box is at rest, then these components should all add up to 0. Consider an object being pushed along a frictionless floor. It is being pulled down by gravity, being pushed up by the floor, and being pushed to the right by the person. It is just as correct to show the force acting at the point of contact as it is to show the forces acting outward from the object, or to show the forces acting on a free body diagram representing the object. Forces always point in straight lines. Even when a force would tend to cause a circular motion, the force is shown as a straight line that corresponds to the object's acceleration at that moment in time. Free body diagrams only include the forces that are acting on the object. Any other vectors that represent the motion of the object should not be included on the free body diagram.